For the slopes quiz, we're focusing on the 5-4 page because it's a little bit more detailed and it's clearly the harder problems, if there are any, for this quiz. So this lesson mainly utilizes the slope formula, which is y2 minus y1 over x2 minus x1. And that's for any set of 2 points. So when you're working on these problems, basically you're trying to find 2 points that you can then substitute into that slope formula. For example, in the first 3 problems, they made it as easy as it can possibly be because they actually just give you a pair of points. So in this first one, this can be x1 and y1, like the x and y coordinate of the first point, and x2, y2, the x and y coordinate of the second point. So if you're going to work out a solution for those, I'm going to bring this over here so I can show my work for it. I'm starting with the formula for slope, and then I'm just going to substitute in the numbers according to the way I labeled them above. So y2 is 9, y1 is 6, and on the bottom x2 is 6, x1 is 3. This is 3 over 3, and when I reduce, it's equal to 1. Alright, so then if we move on to number 2 with the same idea in mind, again I'll label it up here, x1, y1, x2, y2. And this one is going to be 4 minus 7 over 4 minus 2. So 4 minus 7 is going to go down into the negatives. It's negative 3, and 4 minus 2 is 2. Negative 3 over 2 doesn't simplify any further, so that is your answer. We move to number 3. Number 3, we might run into some of the potential mistake areas with these kind of problems where we have x1, y1, x2, y2. If we do the formula, it's going to be negative 1 for y2, and then a minus sign according to the formula, and then y1 is negative 5. And on the bottom it'll be negative 9, a minus sign from the formula, and a negative 1 for x1. So when we have a negative 1 and then we have 2 minus signs here, minus and negative, that's 2 negatives back to back makes a positive, so this is really negative 1 plus 5. And on the bottom, again, we have negative 9 minus negative means plus, so it's negative 9 plus 1. So when I take negative 1 plus 5, I'm going to get positive 4. And negative 9 plus 1 is negative 8. Well, 4 goes into 4 one time and into 8 2 times, and this whole thing is negative because of 1 negative on the bottom. So our answer to that one is negative 1 over 2. So, you know, for those 3 problems, the only real potential for a mistake, as long as you understand what the formula means, is this minus negative thing right here that you want to watch out for, that becomes a plus. Other than that, it's pretty standard. Okay, so then let's move on to number 4. See, this time number 4 shows you a graph. So while you could use the slope formula to do it, my thought is, why would you not take advantage of rise over run since you have a graph? That's what the purpose of this lesson is to show you when to use a slope formula and maybe when not to. So in this case, since it's a pretty simple graph, I would say let's count rise over run. It's obviously a positive line going uphill, so we're going to count up and over like that. So this is up 1, 2, 3. And to the run then is 1, 2, 3, 4, 5, 6. So our slope here is 3 over 6, which reduces to 1 over 2. So in that case, it was easier to use rise over run than it was to use the slope formula. And this is what we'd like to get you guys to be able to do, is to recognize when it would be easier to use one form or the other. That's why you have 2 ways to do it, because in either case, usually one way is easier. Alright, looking at number 5, I see a chart now. So to do rise over run, I'd have to graph this. So it's probably easier to use the slope formula. And remember, when you get a chart, it actually is labeled as an x and y here, but really any chart you have is essentially a list of coordinate points. So we only need 2 for the slope formula, so we might as well just use the first 2 here, right? So instead of reading it as a chart, this is really 0, 25, and 2, 45. So let's label that as x1, y1, and x2, y2, and just use the slope formula. So if I go to use the slope formula here, it's going to be 45 minus 25 over 2 minus 0. And that's going to be 20 over 2, which is equal to 10. Alright, so then we move down to number 6 and 7, what I would think are probably the hardest problems on this lesson. So they ask you to do 2 things. First, they ask you to find the slope, so they're going to give a numerical value, and then it asks you to tell what the slope represents. So for number 6, I would say we're looking at a graph of total pay. The y-axis says money earned, and the x-axis says time worked in hours. So let's first find the slope. Well, on a graph with pretty normal numbers, I would say it's easier to use rise over run. So I'm going to count up this way and over this way for rise over run. But the thing is, when I count, I need to count by what these blocks actually mean. So I'm not going to go 1, 2, 3, 4, because each one of these blocks is not by ones, it's by 20s, as you can see over here. So this is really 20, 40, 60, 80. So a rise of 80. And then the run actually is, if you look at the blocks here, they're by 2s. So again, I'm not going to count 1, 2, 3, 4. I'm going to count 2, 4, 6, 8. So this run is 8. So if I go over here and I do the slope real quick, it's going to be 80 over 8, which is 10 over 1, or just 10. But for purposes of what we have to answer here, it says, what does that slope represent? Well, if you think about it, if the slope is 10 over 1, and the y-axis means money earned, so this is $10, and time worked, hour, this is 1 hour. What we're really saying is that this person is making $10 per hour. Alright, so let's look at number 7, which is about peanut butter. And it looks like you're comparing the jars of peanut butter to how many peanuts it takes to make them. So again, let's do the slope. Alright, this time, if you were going to count rise over run, it's going to be a little bit difficult because, one, your point that you're given is not really on a corner, so it's kind of hard to judge it. And also, these blocks are by ones on the rise, but the blocks on the bottom are by the thousands. In this case, with these kind of odd numbers like this, it's probably easier to use the slope formula. So if we call this x1 and y1, and this one x2 and y2, it would be 9 minus 3 on the top over 4860 minus 1620 on the bottom. And so this is going to be 6, and on the bottom this is, well, 3,240. So we probably want to reduce that if we can. See if maybe 6 divides evenly into 3,240 and try to reduce that down. So it looks like 6 goes into each one of these numbers. It goes into the top number once, and then the bottom number 540 times. So the slope is 1 over 540. The question is what does that actually mean? Again, well, the top number is 1 jar, because it's jars of peanut butter, and the bottom number is 540 peanuts. So if you read it like that, what it's telling you is that you get 1 jar for every 540 peanuts. Or another way to say that is it takes 540 peanuts to get 1 jar. So 540 peanuts to make 1 jar peanut butter. So these are really important problems because it's one thing to be able to calculate a slope, but it's equally as important to be able to say what that slope actually represents. Alright, let's go to these problems with equations then, our last type here. So you're asked to find the slope for each one of these things, but this time you're given an equation rather than just a pair of points. But the thing is as far as you know, the only way to really find a slope is using the slope formula from a pair of points. So I guess that means we're going to have to figure out a couple points from this equation. Luckily, you guys know how to do intercepts. So let's find an x and y intercept. Remember, the idea was that in an x-intercept, the y-coordinate is always 0. So it's essentially like you could forget about this y expression and just solve 8x equals 96, because this will be 0 anyway. And as it turns out, x is 12. And for y, it's the exact opposite. The x will be 0. So it's like you could solve this expression without the 8x and just solve 2y equals 96. So y is 48. So those are your 2 coordinate points. Now you just need to use those in the slope formula and you'll be able to work out an answer. So if this is x1, y1, x2, y2, it's going to be 48 minus 0 over 0 minus 12. 48 over negative 12, and that reduces to negative 4. We're going to end up repeating that kind of process for each equation. First find the 2 points, and then use those 2 points to calculate a slope. So if we go to number 9, the equation is 5x equals 90 minus 9y. So my suggestion to this problem is to be able to do this like we did number 8. You notice that x and y are together. It's probably a good idea and maybe easier to just do one step and say add 9y to both sides, so that this cancels and you have 5x plus 9y equals 90. Then you can solve it that way in the same way we did the other one, because it's the same exact format. So for the x-intercept, y would be 0, and we'll be solving 5x equals 90, which means x is 18. And for the y-intercept, x will be 0, which means we're solving 9y equals 90, so y equals 10. So again, if we do x1, y1, x2, y2, we're going to have 10 minus 0 over 0 minus 18. And our answer is going to be 10 over negative 18, which reduces to negative 2 over 9. Excuse me, negative 5 over 9. So all I did was solve the intercepts like I did just a minute ago. The slope formula is going to have 10 minus 0 and 0 minus 18. 10 over negative 18 and reduce. Alright, so let's do number 10 in the same way. 5y equals 160 plus 9x. So maybe you can see that again we want this 9x to be over here with the y, so I'm going to subtract it away. And that'll leave me with just the 160 on this side. And on the other side, I can put the x or y first, it doesn't matter. 5y minus 9x. So I'm going to solve this one for its x and y intercepts. For x, I'm going to be solving without the y, so it would be negative 9x equals 160. is going to come out to negative 17.8. So sometimes we get a decimal. And for y, it's going to be without the x, so 5y equals 160. So y is 32. So if we do, again, x1, y1, x2, y2, it's going to be 32 minus 0 over 0 minus negative 17.8. So 32 on the top, and this is actually a plus, so 17.8 on the bottom. So you could try to reduce that down if you want, but in this case, all I'd be asking you to do is get to this point, and I'd say you can probably leave it from there. This is an example of a problem that we will show you how to do the slope in a different way, where you can just read it from the equation. But as of now, this is an example of when using the slope formula actually is the longest way to do it. But as you'll go on in this lesson, you'll start to see there are other ways you can figure out slopes, and maybe one of those other ways would be the easiest way in this case. What you might see happen is, in the answer to this one, eventually, the slope would just be 9 over 5. But see, I can tell that just by looking at the equation, and pretty soon you're going to be able to tell that too. Okay, so for the back side of this, we'll go a little bit quicker through some of these because they are very repetitive. And so 11, 12, and 13 again are just the same type with some more practice with points. So this first one will be 1 minus 5 over 3 minus 2. That's negative 4 over 1, or just negative 4. Number 12 would be negative 5 minus negative 5 over 6 minus negative 9. Negative 5, this is really a plus, so this is really negative 5 plus 5, which is 0. And this is a plus 2, 6 plus 9 is 15, but it doesn't matter because the answer to this one is 0. As we do number 13, it'll be negative 1 minus 4 over 3 minus 3. Negative 1 minus 4 is negative 5, but 3 minus 3 is 0. You can't have a 0 in the denominator, so this one is undefined. I'm just waiting for the camera to catch up for a second. Just so you know, then this one would end up being a negative or downhill line. This is actually a horizontal line, and this one is actually a vertical line. Alright, let's keep going with our graph. So we have, again, a table, and then we have a graph. Okay, number 14 is a great example of what would be easiest for you, or for anybody. You know, I want to pick points that would make it pretty easy on me, so why would I use these ones with decimals when I don't have to? Any 2 points will do, so I'm going to pick that one and this one. So I'm going to say 29 minus 22 over 4 minus 2. 7 over 2. Done. See, now if you don't, you use the other ones, you're going to have decimals and get weird answers as a result. But in either case, if you just use the regular numbers, you'll come out to a nice easy answer. Number 15, it's a graph with easy numbers. I would say let's do rise over run. It's downhill, so it's going to be a negative rise. So that's down 1, 2, 3. And the run is 1, 2, 3, 4. So this slope is negative 3 over 4. Okay, when we get to 16 and 17, again, we might be running into that situation of, is it easier to just use the points that are given and use the slope formula rather than count? I would say that counting by these grids are both probably pretty tough. So let's use the slope formula instead. So I'm going to call this one x1, y1, and this one x2, y2. And I'm going to do negative 15 minus negative 40, and 5 also minus negative 40. So this is negative 15 plus 40, that's going to make for 25, and 5 plus 40 is 45. So if we reduce those by 5s, 5 goes into this one 5 times and this one 9 times. So our slope is 5 over 9. It also asks you, what does it mean? Well, this is Celsius degrees and Fahrenheit degrees. So what we could say is, for every 9 degrees Fahrenheit, you'll go up 5 degrees Celsius. Let's look at number 17 also with the same idea. We can call this one x1 and y1, x2, y2. 207.5 minus 212.9, 2500 minus negative 500. So 207.5 minus 212.9, it's going to give us a negative number. Negative 5.4. And on the bottom, 2500 minus negative 500, that's plus 500. It's 3000. So if I read this, then the top is boiling point in Fahrenheit, and the bottom is feet above sea level. So how do I read that? It says to me that it's going to go down 5.4 degrees Fahrenheit for every 3,000 feet above sea level. Okay, so what I'm saying then is the slope represents that you're going to lose 5.4 degrees Fahrenheit from the boiling point for every 3,000 feet above sea level. So we'll write it out like that. So again, when you see a negative, it means you're going to lose something. Losing 5.4 degrees from the boiling point every 3,000 feet above sea level. Okay, I asked you to do number 18, 19, and 20. Again, these are find the slope from an equation. So we'll approach those the same way. Let's find 2 points. So for number 18, 7x plus 13y equals 91. Sorry, 91. So for x and y, I'm going to do 7x equals 91. Which means that x is 13. Then I'm going to do 13y equals 91, which means y is 7. So if I do x1, y1, x2, y2 here, I'm going to end up doing 7 minus 0 over 0 minus 13. 7 over negative 13. If you go to number 19, 5y equals 130 minus 13x. Here again we have that issue with the 13x being on the wrong side. I'm going to add it away to both sides. 5y plus 13x equals 130. And now I'm ready to solve it just like before. To do this one, it would be 13x equals 130, so x equals 10. And this one would be 5y equals 130, so y equals 26. So it's going to be 26 minus 0 over 0 minus 10, and that is 26 over negative 10. That one reduces down, at least by 2's, to 13 over negative 5. Alright, number 20. I'm guessing number 20 is another one that when we solve it, it's probably going to give us kind of a weird decimal, but let's see. Okay, so I would add the 3y to both sides, and we're going to end up with 7 equals 9x plus 3y. So for x and y intercepts, for x it's going to be 7 equals 9x. In other words, x equals 7 over 9. And for y, it would be 7 equals 3y. In other words, y equals 7 over 3. I would say for this one, doing a slope here is going to be kind of a pain because you're going to have a double fraction. I don't think I would do this way, and I'd hate to tell you guys to do it this way. So now looking at this, I would say cancel this one out.
Calling students, please
Don't worry
report to the
about
guidance office. Sierra Corella, Nicole Glover, has